So I'm so happy that I could make your day today and give you numbers to go with your math for the day after that unit on geometry or logic that you guys loved so much. So we're going to do some more definitions today. Not going to be any numbers except for to tell you what angles are, but we'll get to those hopefully tomorrow. Okay. So what are you going to learn today? We're going to define skew lines. We're going to talk about transversals, and then we're going to talk about some special angle pairs that occur when we have 3 or more lines that intersect. Okay, so just a quick definition. Skew lines are lines that are not in the same plane and will not intersect, okay, which is opposed to parallel lines, which we did in chapter 1, or those are planes that do not intersect, which is opposed to parallel lines that don't intersect. So this line and this line down here are parallel. They're not going to intersect. But the skew is a little bit different. They'll never intersect, but they're not going in the same direction. Parallel lines go in the same directions. The skew line here and this line here are never ever going to intersect. So I want you to think about up there on 29 where the Target is and the McDonald's, Burger King next to the airport, and how the road goes underneath another road. Those are a real-world example of skew lines if they were to continue on straight. Obviously, they're going to intersect because we can have ramps to go onto them. But if you can think about it, just right there above the road, those will never, ever intersect. And parallel lines are never going to intersect, but they are going the same direction. Now, parallel planes, we had in Unit 1, were planes that don't intersect. So the top and the bottom of this rectangular prism are parallel planes. The sides, this backside and this backside, are parallel planes. All right, so just quick example. Any of these can be a plane. Remember, we need 3 points. So if I'm going to take the very top, that 5-sided figure there on the very top, I can say that that is plane QUT if I wanted to. Okay, and a plane parallel to that, just as review, would be VZY, and say, and that would be parallel to that QUT. Okay, so I have all lines parallel to QR. So I've got a whole bunch of different lines that are going to be parallel to QR. It's going to be ST. Oops, I didn't draw that very well. It's going to be this VW, and it's going to be the XY. So VW and XY. Okay. 2 lines that are skew to ST. Let's erase these lines so that we can see a little better. So 2 lines that are skew to ST. ST is that front leading side there, this side right here. Okay. Skew means they're never going to intersect, so they're in different planes. So like WX would be skew to that. Okay. This QV would be skew to that. So 2 lines skew would be UV and WX. Okay. All lines that are parallel now to TSXY. Getting rid of these lines. Lines that are parallel to the plane. So you got this plane S, X, Y. So the lines parallel is going to be this QR and the VW. So those are the lines that are parallel. Okay. More examples. I've got this triangular prism, and I want to know, remember that's the sign for parallel, is AB, this line right here, parallel to DE? And yes, that's going to be true. Big true. Okay. I've got plane ABE, which is the one that's in there, and plane ACF. So here is plane ABE is this plane right here. And then I've got plane ACF. And you can see that they intersect in AD, so those are definitely not parallel planes. So that's going to be a big false. I'm going to erase those. And now I've got plane ABC, which is the triangular, and plane DEF, which is the other triangle, and those are definitely both parallel, so that's true. Then AD, BE are being asked if they're skew, and they're not. While they're going to definitely not intersect, they are not, they are parallel. Okay, so they're in that same plane. So they're in that plane with the ADBE. Okay, so now I've got some lines here, and I've got this line that intersects both of them. So I've got a line here, and a line intersecting. The line that intersects is a special line, and it's called a transversal. And it's a line that cuts through two or more lines. And what we're going to find is that the angles made by that transversal and these other two lines have special names and special relationships. Today we're just going to concentrate on the special names. So the first kind is a corresponding angle, and it's an angle that's on the same side of the transversal and of the two lines. So for example, here's angle 8, and here's angle 6. Okay. It is above that line, it's above that line, or the angle, so they're both above a line, and then they're on the right side of the transversal, so that's a corresponding angle. So angles 8 and 6 are, but so are angles 1 and 3. So angle 1 and angle 3. Okay. 8 and 6, like I just said. 2 and 4 are both below the two lines and to the left. And then 7 and 5 are also below the lines and to the right of the transversal. So those are corresponding angles. We also have what we call alternate exterior angles. Now, when we talk about the exterior, we're talking about outside the lines. So basically, everything that is outside here is outside the lines, and they're exterior. Alternate means they're on opposite sides. So, for example, angle 1 and angle 5. So angle 1 and angle 5. They're both outside and they're on opposite sides of the transversal. Okay. Angles 8 and angle 4. Okay. Outside and on opposite sides of the transversal. 8 and 4. And those are the pair that we have. Alternate interior is a very similar concept. It's everything that's inside and on opposite sides. So if we're going to go inside and on opposite sides, 7 and 3 are alternate interior, and 2 and 6 are also alternate interior angles. So 7 and 3 and 2 and 6. The last special pair we have depends on your state, your textbook, your curriculum guide, are called either same side interior or consecutive integers. So they are on the same side of the transversal and inside. So 7 and 6, same side, inside, and inside. And then 2 and 3. Okay. So we've got angles 2 and angle 3, and angle 7 and angle 6. So just as a recap, take a minute and see if you can answer these questions. Angle 1 and angle what are corresponding angles? Angles 1 and angle what are alternate exterior? And so on and so forth. And when you're ready, you can pause it, and when you're ready, here are your answers. Okay, 1 and 6 are the corresponding. Okay, 1 and 8 are alternate exterior. 6 and 4 are same side interior or consecutive, and 6 and 3 are alternate interior angles. Okay. So I just wanted to really get you to understand and know what skew lines are, what transversal lines are, what same side interior or consecutive angles are, what alternate interior angles are, what alternate exterior angles are, and corresponding as well. So you should know those definitions. Tomorrow we're going to explore the relationship that all of these have to each other. So have a great evening. I'll see you in class.